When we consider what we have here, functions and limits, when you consider the term function, it has to do with the relationship between two or more variables. And we consider a variable or a function f of x is given as a function x squared plus 3x plus 2 is a function. And f of 1 as a representation of this can give us 1 squared plus 3 in bracket 1 plus 2. So we have 1 plus 3 plus 2, and that is 6. So in function, we can have function of single variable and function of multiple variables. So function of single variable is what we have here. We have function of multiple variable. F of xy is given as x squared minus xy plus y squared. And if I say f of 1, 0, that means we are saying here that x is equal to 1 and y is equal to 0. So when we substitute this into this function, the function values will be retained as f of x of y is equal to 1 squared minus 1 multiply 0 plus 0 squared. And we have 1 minus 1 plus 0. 1 minus 1 is 0. 0 plus 0 is 0. So this is function of single variable, and this function of two variables. We can have function of three variables. F of x of y of z is equal to x raised to the power of y plus y raised to the power of z. And we are asked to find f of 2, 1, 0. If you want to solve this, you substitute the values of x, y, and z into this expression. And we have x, which is 2 raised to the power of 1, plus y, which is 1 raised to the power of 0. And that 2 raised to the power of 1 is 2, plus 1 raised to the power of 0 is 1. So the answer is 3. So this is function of 1, 2, and 3 variables, respectively. We can talk about limit of functions. When we consider limit of function, it has to do with what we call differential gradient or gradient of a function. The limit of a function can be estimated by using the gradient of the function. When we consider this, we have a curve that is moving from a point as this, y-axis and x-axis. Let's say that we are looking for the gradient. The gradient here, which is delta y, and here is delta x. So delta y over delta x is the gradient function of the curve. Gradient function of the curve f of x. So this curve is curve f of x. So if we have to find this, we need to look for how we can get the limit of the expression. If we are given that we have f of x is equal to x squared minus 3x minus 2, and we're looking for the limit of this as x tends to 1. As x tends to 1, we substitute the value of x is equal to 1. So f of 1 is equal to 1 squared minus 3, bracket 1 minus 2. So we have 1 minus 3 minus 2. And 1 minus 3 is minus 2. So we have minus 4 as the limit of this. So the limit of a function can be found by substituting the value of the variable into the given function. The limit is very important in dealing with function and the continuity of it, whether it's going to end at infinity or it's going to be restricted. So the limit of a function is very important in dealing with calculus. So we consider something of this nature. Limit function of x tends to 0. We have x squared minus y squared over x plus y. How do we simplify this? When we have something like this, we can deal with this and say x tends to 0 and y tends to 1. X tends to 0 and y tends to 1. In this case, we substitute the values of x equal to 0 and y equal to 1. So when we slot in the values here, the limits of the expression x tends to 0 and y tends to 1 will now be equal to 0 squared minus 1 squared divided by 0 plus 1. And we are going to obtain 0 minus 1 and 0 plus 1 is 1. So we have minus 1 over 1, and that is minus 1. But we can also solve this in another way by factorizing this term. When we have x squared minus y squared, using the difference of two squares, we have x plus y, brackets, open, x minus y. So we can simplify this and say s squared minus y squared divided by x plus y equal x plus y, x minus y divided by x plus y. So x plus y cancel x plus y. So we have x minus y. But limiting it with these values, x tends to 0 and y tends to 1, we have 0 minus 1, and that is 1. So we see that we have the same set of answers. But certain limit can tend to infinity. When it tends to infinity, when we have something like x raised to the power of 2 plus 3x plus 1 divided by x raised to the power of 2 minus 2x minus 5. And we are tending this to infinity. Limit x tends to infinity. When x is tending to infinity, what are the values of the function? When we have this, we have to look at the highest power of x. And when we look at the highest power of x, how do we solve it? Okay, we divide the highest power with the all the variables. So we divide through with x squared. So we have x squared divided by x squared plus 3x over x squared plus 1 over x squared divided by x squared over x squared minus 2x over x squared minus 5 over x squared. So when we simplify this with limits, x tends to infinity. So we have this as 1 plus 3 divided by x plus 1 divided by x squared divided by 1 minus 2 divided by x minus 5 divided by x squared. So with this, x tending to infinity will now be equal to 1 plus 3 over x will tend to 0, 1 over x squared will tend to 0, 1 we bring constant, 2 over x will tends to 0. So we have 0. 5 over x squared will tend to 0. So at the end we have 1 divided by 1. The answer is 1. So when we have powers of x with values of x tending to infinity, we can solve it by dividing with the highest power of the variable. So at this point, we want to come to an end of today's lesson. Thank you for listening.